Hi, I'm Gilad, Director of Product at Iguazio, and today we're going to cover the production-first approach and how to scale up your ML operations. Now, in terms of the problems to scale with MLOps, there are several challenges. The first one is actually around the organization. So there are different people or different roles. There's a data scientist and a data engineer, and the data scientist may require data and need to ask this data from the data engineer. Or when the data scientist needs to deploy the model, how do they deploy the model and how do they run in production? They would need a DevOps engineer to assist them. So there's a whole back and forth that is happening especially in large organizations. There's also a very complex technical process. So think about what's needed in order to deploy. There's a question of how to package, how to secure everything, how to test, CI/CD, automation, monitoring, versioning. There are a lot of moving parts that you don't necessarily want the data scientist to have to deal with. Furthermore, there's a whole question of accessing to features. So usually a data scientist would train the models in batch. What happens if there's an access to features such as the average amount that someone spent in the past 3 months? Later on, when you get to deployment, and especially in real-time deployments, how does one access that feature? This is often happening when features are not first-class objects. So thinking about features later on makes it more difficult later to deploy them and calculate them and use them in production. And finally, around monitoring, it's not just monitoring the latency or the performance the threshold of the model, it's also understanding the actual how the model behaves. Models are probabilistic in nature. So how does one understand whether the result makes sense or not over time? And we also see that the world changes. After COVID, we see that a lot of people's behavior change. Before COVID, people's behavior change. How do you account for that? And what do you do in terms of automation for retraining the model or tuning the model or creating a new model and so forth? So there's a lot of automation and a lot of capabilities that are needed around scaling the whole operations in order to support this. And at Iguazio, that's our main goal, to change that reality. And we see from our users that this really has a significant impact. And the real impact is when we try to measure the amount of time it takes our customers to take model from development to production. And often we see that before all these optimizations that we are working on, it may take even over a year. And we can even bring it down to a month from the start of developing a project, a model, to the time until the model is deployed. And to give a bit of a sense of the problem, a lot of literature exists around it. There's a similar paper by Google around in 2017 that talks about the model development is a very small part. And if we try to look at it today, it's still the same problem. So if you start to develop the model, the world is very simple. You have some data preparation. You're taking for some data from a batch source. You need to train the model and evaluate it. And at the end, to deploy it, it's just a model endpoint. It's very easy today to just take a Docker image and have a model run and listen in HTTP. This can be done in very short time. When you think about the whole operationalizing the model, all these aspects, there are a lot of questions around data management. So everything around here is around managing the data, getting the data, especially if there's a real-time pipeline involved. How does that data become approachable to the model itself? There's a whole question of automation of the whole process. How do I make sure that what the data scientist writes becomes an automated process? Serving and again, scalability. How do I scale up my operations if I need more resources for my models, and monitoring everything and understanding that everything works? So it becomes a very complex and interconnected picture here, which, if not managed correctly, it will become very difficult. And sometimes the solution is just to bring more headcount, which is obviously not a way to scale up the whole organization. And this brings us to the solution. And we believe that the way to address it is by creating a production-first mindset, meaning by the time the data scientist starts, we need to build the tools and the processes that are already available for them. So once the model is deployed, it doesn't become a very complex task. So if you look at the production pipeline that we offer here, one part is the feature store. Feature store allows us to take those features. For example, if I need to calculate features in batch and serve them in real time and do all of the transformation and make sure that it's not just reading the features, it's also auditing the features in real time. Next, we have what we call here the serverless CI/CD for ML, which allows me to create an abstraction of everything that I need to run and also use serverless in a way that doesn't require me to provision the resources. Everything is automatic. And of course, in terms of integration with CI/CD, the whole process becomes automatic. Next, there is a real-time serving pipeline, which allows me to create transformations before and after running the model, because again, it's not just about deploying a model. The model is just a small part of it. We want to be able to easily transform anything before the model or after the model, or allow the users to chain together different models without having to sacrifice performance and efficiency. And finally, of course, monitoring the feature level and the model level and understanding the whole behavior in the production environment. And this brings us to an improvement that we see almost sometimes it becomes a 12x improvement. Another important part is an abstraction, and we'll cover that a bit more later, but the data scientists usually would like to not have to handle everything about the technology. So if we're using, for example, Kubernetes, we don't want them to have to learn everything about Kubernetes or about deploying and resource management and things like that. So an abstraction layer that allows the data scientists to define what they would like to do in a simple SDK becomes very easy and efficient for the organization. On the development pipeline, there are things that are still important. For example, you still need the ability to train easily and the ability to run in a CI/CD framework and work from your own ID for whatever ID you'd like, integrate with some kind of governance and data quality. These things are important, but it's also important to consider the production side, not just when reaching that point that you need to deploy to production, just from the start of the development process. And if we try to break it down to the different steps that we see in a project lifecycle, this is where we really see the divide. So usually the projects are, when someone starts, are around the development. And we see that most of the failures are around the production side. How to take that model and make it part of a pipeline and scale it up. How do I scale the whole production environment? And how do I make sure that my operations become continuous and I can really create a model factory? If this is left to the end, then a lot of the things break, and either you get a very long time until the model is actually deployed. A year from the start until the end, sometimes it makes the model irrelevant. And it also creates a lot of burden on the organization to re-engineer and work on scalability and continuously trying to improve the system by patches, which doesn't make sense. And the right way that we see it is to think about the chain end-to-end. When we say end-to-end, not just the end is when the model is developed, is when the model is actually deployed and is part of a continuous process of the production pipeline. And this allows a much smoother process that lets the data scientist focus on developing the model, and still the organization and the business gets a lot of value from it, and the whole operations scales up very nicely. So let's talk about the solution. And by the way, the solution that we'll talk about is an open source that we have built, and you'll be able to leverage that even from now. So the first part is the abstraction part. So the data scientist needs the ability to define what they like to do, and sometimes they don't really want to handle everything. For example, how is it going to run? Or they want to test things locally. And we want the data scientist to be able to define functions that are abstract in a way that they have the code, but I don't necessarily have to say, okay, they just run on my notebook or on my laptop. I want them to be able to run on whatever hardware I'd like, whatever environment. And we want them, when we get to production, that no one needs to rewrite them. We want them to be able to say, okay, this is the function, and now I'm going to use it in different contexts. If I run as part of a CI/CD pipeline, it's going to run as part of a CI/CD pipeline. And another important property is that we want them to be able to chain together different functions. So kind of think of Lego bricks that I want to connect together to create some kind of structure. Same idea that I want to take those functions and interconnect them very, very easily. The next thing is about data processing. So consider not just the model development, but how do I process the data? If the data scientist defines some kind of transformation, we want to be able to take it very easily to production without, again, having to rewrite the process itself. And this, again, brings us to the concept of functions. So if I can define functions that process this data and support any kind of data source, then that creates a pipeline that is very easy to manage. And when I get to the production deployment, it's very easy to do that as well. Furthermore, we have the monitoring part. So the monitoring should be something that is relatively seamless. Once I deploy the model, we want ideally to be able to monitor the model from the moment it's deployed. And each model will create an output stream that allows the user to know what's happening and create metrics that allows us to know what's happening. So let's say every interval, every hour, every day, doesn't matter. I can process this output stream, compare it to whatever I use in my training process, or compare it to some kind of ground truth that I gave the monitoring process, and provide inputs to the users on the behavior, on the feature level, on the model level. We don't want this to be something that someone sets up by just having to think again about the whole process. This has to be as automatic as possible. And speaking of automation, the whole process of getting the data, training, deploying the model, setting up the monitoring, the whole thing needs to be as automatic as possible. It means if I change my model, I need it to run for the same automation process. If I change something in the code, if something in the data changes during the training, even if we think about applying patches, security patches and things like that, you don't want to, again, go through all these manual processes. You want the best ability to create automation. There should be areas where you may want some oversight. So some user would need to look at the result and compare, or maybe deploy things as canary model or champion challenger. But the whole process that we just discussed should be as automatic as possible. So the solution I alluded to earlier is an open source solution that allows you to orchestrate the whole process. This is called MLRun. It's an open source that we created. And the idea of MLRun is that you can do all these steps that I just mentioned very, very easily. So you have the ability to create jobs and models and orchestrate them, to containerize everything automatically. Experiment tracking is part of a built-in process when running these jobs. Everything is reusable. There's also a built-in feature store that is usable as part of the whole process, model registry and monitoring. And the way that we have built it is that we built it based on layers. There is a real-time and online feature store and data connector that allows data processing very, very easily and connect virtually to any type of data, whether it's batch or real-time. There's a serverless engine that reduces a lot of the burden from the user to provision resources. So everything runs as serverless, the jobs run as serverless, the model serving runs as serverless, and there's a lot of capabilities that we have built that allow us to optimize the whole process. And when I talk about serverless, I'm not talking about a specific platform. So everything can run on whatever platform you like. We'll run on Kubernetes, whether it's on-prem, whether it's at cloud. It's something that runs on top of it. Specifically for the model deployment, we're using Nucleo, which is an open source that we have developed in the recent years for serverless functions. And you also get a function hub that allows you to reuse different functions between different groups and different data scientists and different users. The whole process of ingesting, training, deploy, and monitoring is part of the process, and you have the ability to define functions that run in each one of these contexts and assets around these MLOps processes. And everything is automated in terms of the fact that you can create projects and deploy things to CI/CD, and makes it very, very easy to take those functions and reuse them in that context. So with regards to functions, this is the main abstraction that I mentioned earlier. A function allows you to just take your code. So you can take Python code and say, I want to run it as a function. You can run it from Jupyter. You can take it from a Python file or from some Git repo. You can define different runtimes. So you can run it on Kubernetes. You can run it as something that is distributed, such as Dask or Horvath, using Spark, or deploy the model as a Nucleo. Define the image. And also, we can create images on the fly for testing, or if you want to add more Python packages as part of the image, and define what resources you like to use. And these resources allows you to scale up and scale down as needed. So you can even define number of maximum instances, minimum number of instances, and so forth. And this abstraction allows you to later take this function and deploy it on different contexts, because even if you run it locally on your Jupyter instance, then you can run it on Kubernetes, and then you can run it in a parallel manner. It makes it much easier to do things rather than the norm or the default that someone would just use, which is just write a bunch of code. The data is not segmented correctly, or there is no right way to define where is the data, where is the model training, where is the model deployment. It's much harder later to deploy things, because then someone needs to take this very complex code that someone wrote and break it down to something that runs in production. And again, think of the Lego blocks as the best analogy here. Those functions are interconnected. You can reuse functions across different projects, deploy those functions or save them in GitHub, and use them as required. So it makes it very easy to not just every time write your functions, but reuse them, because there's a lot of code reuse that is usually applicable. For example, check the training code or serving code, or even data processing. There are a lot of things that we see across projects are reusable, and rather than rewrite them, again, allow the data scientists to focus on the core issue that they need to develop a model, and not everything that need to be managed in terms of code that someone maybe already has done before that. And we have seen these examples from different kinds of fields or different customers, in whether it is around operations or around predictive maintenance, that someone needs to react relatively quickly, risk applications, real-time recommendations, even when taking large amounts of sensor data and processing them in real time. In manufacturing, NLP is around creating a pipeline that allows us to process text-based data and create a pipeline that is very, very efficient. Rainfall prediction, we have an example of a user that took CCTV input to predict rainfall and predict floods. And anything that around large enterprises that need to change the whole behavior of their large organization and leverage AI and take them to the next level. So if you'd like to start with MLRun, the best option is to just go to the GitHub repository. We also have a website called mlrun.org, which gives more information and that was detailed here. And we'd like you to really benefit from it. That's why we built this open source, either as a user or if you'd like to contribute. We'll be more than happy to work with anyone in the industry. And this is pretty much it. If you'd like to contact us, feel free. You can contact me on LinkedIn or go to iguazio.com, and we'll be happy to chat and talk about your use case and challenges around scalability. Thank you.